Good afternoon, 8th graders. Unfortunately, my daughter has a fever, so I had to leave a little bit early. So if some of you have seen me and were confused, that is why I am no longer here. Today, we are looking at our second day of the exponent multiplication rules. Yesterday, we expanded our expressions and then counted how many x's and how many y's and so on. Today, we are going to talk about our shortcut that we kind of referenced a little bit yesterday. So if you would, please make sure that you have the answer key from the front. Sorry, the note sheet from the front. If we take a look here, we can remember that you can rewrite expressions in simpler ways by using multiplication in place of repeated addition, and by using exponents in place of repeated multiplication. Rewriting expressions in different forms can be a powerful tool for simplifying expressions and seeing patterns. So we can see here that a plus a plus a plus a is just repeated addition, which is 4 groups of a. Repeated addition is multiplication. We recognized yesterday that something like y times y times y times y times y is actually just repeated multiplication. Repeated multiplication is the next step up. That is your exponents. All right, that's actually why the order of operations has exponents before multiplying, because exponents is repeated multiplication. So remember yesterday, what we did is we took this a cubed and we wrote it a times a times a. We took the a to the 4th power and we multiplied a times a times a times a. A few of you started recognizing, well, that's a little bit extra. Why can't we just see that there's 3 a's multiplied together plus 4 a's multiplied together, giving us the 7 a's? Well, that's what we're doing today. If we take a look here, there are 2 x's and 4 more x's. That is what gives us this 6x. There are 3 y's and there are 2 y's, so that is what gives us this 5y. All right. The product of powers property, this is something that you need to write down on your piece of paper. To multiply powers with the same base, we add the exponents. For example, on a to the 3rd power times a to the 4th power, we get a to the 3 plus 4, which is a to the 7th power. Let's take a look at some examples. I'm seeing here that we have the same bases. It's important that these have the same bases. Because they have the same bases, we can take the 2 and the 7 and add them together. So we get 3 raised to the 7 plus 2, which is 3 to the 9th power. Taking a look at our next problem, we've got the same bases on each one of these, which means we can take our 3 exponents and multiply them together. So our base is x, and we get 4 plus 3 plus 8. That is 7 plus 8, so it is x to the 15th power. On the next one here, we've got a situation where there is more than one base. We've got c's and we have d's. Remember yesterday we talked about exponents are only attached to the thing that it is touching. The only way on this second equation here, the second term, for this 7 to be attached to the c is if there was a set of parentheses. This c, when there is no exponent, actually has an exponent of 1. All right, so the c is being raised to the 6 plus 1 power, and the d is being raised to the 5 plus 7th power. So in total, we have c raised to the 7th power. There would be 7 c's multiplied together. And here we have 5 plus 7, which is 12 d's that are multiplied together. Remember yesterday we looked at when we have a exponent raised to a power. This one here, we expanded it yesterday. We had y cubed raised to the fourth power, which means there are 4 y cubes multiplied together. That is 3 plus 3 plus 3 plus 3. Repeated addition is multiplication. So this is actually y to the 3 times 4, which is y to the 12th power. When we have an exponent that is raised to a new power, we multiply the exponents. If we take a look on B, this is 5 to the first power times c to the second power, and that is done 3 times. That's 5 to the first times c to the second, times 5 to the first times c to the second. We have 1, 2, 3 5s multiplied together, which is 5 to the third, and here we have c to the 2, 4, 6th power raised here. If we take a look, yesterday we kind of referenced that it was like the distributive property. Remember, the distributive property is where we multiply everything inside. That 3 is multiplied by each of your exponents. So it's like 5 times 1 times, or 5 to the 1 times 3, and c raised to the 2 times 3, which is 5 to the third power times c to the 6th power. So the power of a product property says to find the power of a product, we multiply the 2 exponents, or however many exponents there are. So on that y to the third power raised to the 4th power, we're multiplying 4 by 3, getting y to the 12th power. Let's do some problems. Here, the base of the problem is 3 to the 5th power. The exponent is 2. So that is 3 to the 5th power times 3 to the 5th power. 5 plus 5 is 10. That's 3 to the 10th power. The next one, we have z to the 6th multiplied by itself 4 times. Repeated addition is multiplication. So that is z to the 6 times 4, and that is z to the 24th power. The next one is n raised to the 9 times 6th power. 9 times 6 is 54. I don't know about you, but I would not want to have to write out 54 n's multiplied together. That's why we come up with these rules to help simplify our expressions. Let's put it all together. When there are, we have to look here and see that there are inside here 3 different terms that are all being raised to the 4th power. So the 3 gets raised to the 4th power. The r to the 3rd power gets raised to the 4th power. And the s squared also gets raised to the 4th power. So we come out with 3 to the 4th times r to the 12th times s to the 8th power. We can go a step further and actually do this exponent. This would be 81, because that's 3 times 3, which is 9, times 3, which is 27, times 3 again, which gives us 81. So 81 r to the 12th, s to the 8th. Recognizing here, there is a number expression and 3 terms, or 3 variable pieces. Notice those variables are in alphabetical order. The order that we always put these in is any numbers, then alphabetical of your variables. So the 10 gets cubed. The a to the 5th power gets cubed. The b to the 8th power gets cubed. And the c to the first power also gets cubed. So 10 to the third power, that's 10 times 10 times 10. That is 100. Sorry, 1,000. A to the 5 times 3, that is a to the 15th power. B to the 8 times 3, 8, 16, 24. And lastly, we have c to the third power. All right. It's interesting, my 7th graders today were doing things like this: 3 times x plus 2, and then adding 2x. These are very similar to each other when we're looking at the exponents. On a problem like this, when I did with my 7th graders, they had to first distribute the 3, so we get 3x plus 6, and then plus 2x. They then had to combine like terms, and they got 5x plus 6. That was their final expression. Similarly, in letter C here, we first have to cube everything inside the parentheses, so that is 4 cubed times x to the 2 times 3 times y to the 3 times 3, and then we have to include this x to the 5th power. So we've got 4 cubed times x to the 6th times x to the 9th times x to the 5th. Now we can combine any other terms that are here. I see that we have 6 x's plus 5 more x's here. This is 4 to the 3rd power. That is 4 times 4, that's 16 times 4. That is 64. X to the 6 plus 5, which is 11. Y to the 9th power. So similarly, when we have an extra term that's multiplied, it's like when we have an extra term outside of a parenthesis in a distributive property situation. Give the next one a try. I'm going to pause for a moment here. Let's have the video pause, and I want each of you to try letter D here. So once we are trying this, we have to first distribute our exponent of 5 to each one here. So that's 2 to the 5th power, m to the 15th power, and n to the 10th power, times, this one also gets distributed, 7 squared times m to the 8th power. Now, 2 raised to the 5th power. If you're looking for the exponent button on the calculator, it's 2, and then there's a little arrow up, 5. I think it's on the right side of your calculator. 2 to the 5th power is 32. And then there is the m's that need to be combined, but also the 7 times 12, or sorry, 7 times 7, so that's times 49. The m's are added together. We have m to the 15 plus 8. 15 plus 8 is m to the 23rd power, and then n to the 10th power. Last thing that you would have to do is do the actual 32 times 49. That's 1,568 times m to the 23rd and n to the 10th power. If you kept it as 2 to the 5th power times 7 to the 2nd power times m to the 23rd times n to the 10th, this is also something that I might that I would not mark incorrect. Similar to putting our letters in alphabetical order, if you were to do something like this, make sure that your numbers are in numerical order, meaning I have my smallest number, my smallest base on the left side, moving up from there. Looking at this problem here, one study team rewrote the expression 10 cubed times 5 to the 4th power as 50 to the 7th power. I want you to talk with your team right now. What do you think about this? Is this correct? Is this incorrect? come up with some reasoning. Go ahead and pause the video and talk about that as a team. Now, hopefully you said that this is actually incorrect. At the beginning of the lesson today, I talked about how the bases when adding exponents together must be the same. In this situation, we have a base of 10 and we have a base of 5. That's like having a base of x and a base of y. We cannot combine those together. They have to stay separate. So there is actually no simplification in this situation other than saying, you could simplify it as in saying that this is 1,000 times 5 to the 4th power, which is 625, but you cannot combine that together to 50 to the 7th power. This here would actually turn out to be 625,000, and 50 to the 7th power, let's see, 50 raised to the 7th power is a humongous number. It is so large that the calculator cannot write this without using scientific notation. That was 7.8125 times 10 to the 11th power. Remember, raising something times 10 to the 11th power means we would have to move this decimal 11 times. That's quite a bit bigger and different than 625,000. Okay? Do not multiply bases together. If they have different bases, you cannot combine them using these rules. Simplify both of these expressions and then be able to answer, how are these two expressions different from each other? This is our last thing that we are going to be doing until you will have some time to work on your homework. Taking a look at the first one. This is 3 20s multiplied together, multiplied by 8 more 20s. This is 20 to the 3 plus 8, which is 20 20 to the 11th power. Where b is 20 cubed multiplied by itself 8 times. So that's 20 cubed times 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 20 cubed, and I believe there's one more 20 cubed. Notice this is 8 groups of 3. So this is 20 to the 3 times 8 instead of 3 plus 8, which is 20 raised to the 24th power. When we are raising bases of exponents to new exponents, we multiply. When we multiply exponents together, we add. A mistake that was brought up to me today is if you actually look at day 1 versus day 2 in your homework packets, day 2's assignment is literally the exact same, except for they have different numbers. Or sorry, they just have different formatting. So with that said, you need to first finish day 1's assignment. If you have not finished day 1's assignment, that is what you need to do right now. If you have finished day 1's assignment, I have an online assignment posted to Google Classroom that you need to work on. All right. This is not time to be playing games. This is time to be practicing with your exponent work. Please make sure that you are doing something productive over the next period of time. I will see you all tomorrow. Have a wonderful rest of your day.